Hey everyone, today I'm going to be showing you a self-powered pump. Now if I put one end of a tube in the water and then suck it out, you'll notice that the water level in the tube only goes as high as the water level in the glass jar here. So if I lift the tube higher, the water falls down in it to always stay level with the water in the glass jar here. If I move the outlet of the tube lower than the water level in the jar, then it will start flowing. But you'll notice that I can't get the water to flow back into the jar itself. So even if I start it flowing and try to put it back in, I can't do it. The way to do it is with something called a hydraulic ram pump. And what this is just two check valves and then a hollow PVC pipe here. Okay, so what I have here is just a bucket of water, and I have the water flowing down through this tube, through these PVC pipes, and then it goes up this other clear tube all the way to the top of my ladder here. So the outlet of this tube is much higher than the water level here. But watch what happens when I open this valve. It starts pumping higher than the water level. It's going all the way up here. Look at this. It's even flowing back into the water bucket. Now I'll remind you, there's no external source of power here. All I have is a bunch of tubes and valves connected together, and it can pump the water back into the original bucket. Let's get this pipe here and see how high it can actually go. Okay, so I'm gonna hook this in the end here. Let's see, this is another 8 feet about. Let's see if we can get all the way to the top of here. So there's no source of power here. Come on. Okay, it did it. Look, it's coming out the top. So this is going about probably 10 feet above the water source with no external source of power. So the water's starting here, going down this tube, through here, through this valve, through this check valve, through here, all the way up this tube to the very top and back in the bucket itself. So how is this possible? Well, one crucial thing to notice is this waste valve here. I'm wasting water as I'm pumping the water to the top here. So eventually I'm gonna lose all the water in my bucket. So I have to fill up my bucket again. So by putting in more water, I added energy to the system. So it's not perpetual motion. The working pieces are actually this valve and this valve right here. Without them, it can't work. The valves moving inside here look like this. These valves opening and closing occur naturally, and the frequency of it depends on how high your bucket is and how high your outlet of water is. You start the pump by holding down the waste valve so water begins flowing out of the waste valve. And as water flows out of the waste valve, it catches the flap and it pulls it shut. But the water that was moving through the tube suddenly got slammed to a stop, and so it had kinetic energy that has to go somewhere. That kinetic energy then gets turned into high pressure in the tube. Then that high pressure opens up the second valve and forces water through it. Well, what's this thing for? Well, this is just an empty PVC pipe that has air in it. So because the air can be compressed in there, it's kind of like a spring for the movement of the water. You want this to be filled with air to allow some springing motion so the water doesn't just slam and have too high of a pressure spike through it. So these are great pumps that can be used in off-grid settings where you don't have any source of power to your pump, and you can put it in a stream or a waterfall somewhere and pump water to a higher level than the source water. If you're gonna try to make one of these work yourself, it takes a lot of playing around with. You have to get the pressures exactly right to get the continual opening and closing of the valve. If you don't get everything just right, the valve will either stay perpetually shut or open. It won't do the closed and then open, closed and open all by itself. One thing that helps get this started is you have to make sure that you have enough head pressure to begin with. So you have to make sure that the pressure on the inlet is enough. And you also have to make sure that you have enough height on the outlet as well. If you don't have that high enough, then it's hard to get it started. This pressure wave that's pushing the water uphill is actually the same reason why sometimes you hear a big bang when you suddenly shut off a valve in your house. That's because that water's moving really fast through your pipes, and you suddenly shut off that valve, it gets slammed to a stop. And that slam to a stop actually causes the pipes to expand a little bit because of the increase in pressure and then collapse back down. So it creates a big bang sound. This is called